Hello everyone, thanks for taking the time to listen to me today. I'm an ecologist who works at the University of California, and I work on the problems of trash in our oceans. And you might be surprised to find out that the most abundant form of solid waste pollution that we find aren't things like bottles or packaging. They're in fact tiny fibres that make up over 85% of the material that we find on shorelines worldwide. From the poles to the equator, across all 6 continents, this is by far the largest solid waste problem that we have in our habitats today. When we've treated the environment as a crime scene and used those sorts of forensic techniques that you see on the shows such as CSI, we found that the types of fibres that we find match almost entirely those used within the clothing industry. And we showed that in areas where sewage is added to the environment, we get 250% more of this material. This led to pioneering research that showed that each time each of you put an item of clothing into the washing machine, this is going to release thousands upon thousands of fibres through wastewater and into habitats worldwide. The problem's quite simple. Clothing fibres are now the most abundant form of material that we find worldwide, and it's getting worse. The amounts that we find in the 60s or 70s are dwarfed by the amounts that we find in the 80s and also today. This has led to widespread concern amongst the international media, such as articles in the BBC, but also leading scientific journals such as Science, including policymakers in the US and also the European Union. But it's not just a marine issue. Our recent research shows that this type of contamination extends far beyond the marine realm to freshwater rivers and lakes, even to the land where sewage is now added as a fertilizer to many crops. More worrying is that the air that we breathe is shown to be contaminated with these tiny fibres. Why should we really worry? Well, our recent research in Nature showed that well over 78% of the most persistent, bioaccumulative and toxic chemicals recognised by the US EPA are found on these types of material. In fact, from the production process through to the washing process, through to what we find in the environment, these concentrations can be 1 million times greater on these tiny fibres than what we normally find in seawater. What's the impact? Well, the impact's quite clear. The wildlife is contaminated with these tiny fibres. Mussels that are able to eat these types of particles, including many other types of organisms. The particles transfer from their stomach and accumulate in their blood cells, and they don't detoxify. You continue to find these particles months later. This means that the very food that we eat is contaminated with these tiny particles. This is a blood sample that I've taken from that mussel that's been exposed to the plastic. The green area is the outline of the cell, its blood cell, and that yellow spot is a fibre-sized fragment that's clearly in the middle of its lysosome. It's not just a problem for wildlife, this is also therefore a problem to humans, because it's yet another route of exposure by which fibres could transfer into the human food chain. Benign by Design is a team of engineers and scientists from government and also from academia that's based in Santa Barbara, but with offices and laboratories in Davis, Chicago, and Sydney. And we're here to try and help you tackle this problem. In 5 words, we can be described as cost-effective fabrics with minimal impacts from grave all the way to cradle. And it's really a systems approach that I'm going to talk to you about today for choosing fabrics so that we can minimize these impacts and also enable fabrics that emit fewer toxic fibres to the environment. This works by looking at the impacts across grave to cradle, and then once we've identified some possible fabrics we'd like more information on, we form an integrative, collaborative working group made up of representatives from industry, government and academia that's centred around using a trade-off analysis to find the best possible fabric. Well, how's this done? We combine existing information from indices such as the Higg index that has information about greenhouse gases, water impacts, cost, which is important to the bottom line of companies, as well as the chemicals used in the production process and also those that absorb onto the particles once they're in the environment. We then integrate this with brand new data that we've developed systems to actually measure in terms of the emissions of fibres from fabrics, their impacts on the environment to humans and wildlife, as well as the durability of those fabrics themselves. This is all put together in a trade-off analysis that allows us to find the best possible fabric that we could use. This is unique because all apparel eco-indices neglect the impacts and emissions of fibres to the environment. And there are question marks as to whether or not an index is the most useful approach for this, because you're comparing apples with oranges. The impacts associated with water are very different to those associated with carbon dioxide or toxicity. And what we believe may be a more useful approach to integrate this data is a trade-off analysis, because this keeps the data in its original form and allows us to make better decisions. We believe that this will break down the barriers that is holding the apparel industry back from creating truly eco-friendly fabrics. We believe this is going to be a game changer, because better fabrics that emit fewer fibres and are less toxic is going to result in a cleaner world. We believe this will improve the performance in companies, and it will also mean that we don't need government regulations to sort out this issue. We'll be able to do it at the source. Our team of network researchers is ideally placed to do this. We've got experts at the University of Sydney who have developed award-winning practices to actually measure these types of emissions into the environment and also their impacts on humans and wildlife. We've got experts in human and wildlife toxicology, experts and engineers who have actually developed filters for washing machines to remove some of these fibres. We've also got colleagues in the EPA and the Green Chemistry Division, and also expertise in TSCA, as well as those who work on the impacts of nanomaterials that are frequently added to textiles, as well as people who work for the United Nations Environment Programme, helping them with their life cycle assessments, together with collaborators in our international working group, which is looking at the issue of marine debris, that use trade-off analysis each and every single day to help companies improve their bottom line and also have more eco-friendly products. Our vision's quite simple. We want a focused R&D approach to this that shapes the market and enables us to generate the types of information to build the next generation of fabrics, those that emit fewer fibres and those that are much more biocompatible. But we need your help, which is why I'm here today. We need to generate awareness of this issue within the industry, which is where I think you can help. I also think that we need to further develop an agenda for research that not only looks at the biocompatibility of the major types of polymers we find, i.e. the ones that are least toxic, but also looks at how the different physical structure of fabrics in terms of their knit affects how many fibres are emitted. We also need to understand the persistence of these types of fibres in humans, habitats and wildlife. And through this, we believe through partnering additional organisations, we'll be able to integrate the data that we've collected together with existing indices to execute an agenda for research that develops the necessary platforms and tools for you guys to make better decisions. Through this, we believe we'll be able to generate some best case practices and also build the ecosystem to actually fulfill this research. That's it. Thank you very much for listening, and I look forward to your feedback.